Hello viewer, welcome to my one more new videos. In this video, we are going to calculate the center of mass and center of rigidity of final year project of a buildings. Here we are going to using the simple way to calculate the center of mass and rigidity and fast method where you can calculate the center of mass and center of rigidity of your building in a final year project. First of all, so we should have to know that what the center of mass and what the means of center of rigidity. Center of mass and center of rigidity are discussed about in 1893 to the part 1 2016. The center of mass is the point in the floor of the building through with the resultance of the inertial force of the floor considering act in the earthquake, in the shaking, and unless otherwise state the inertial force and consider it associated with the horizontal shaking of the buildings and center of rigidity of the single floor building and the multi-story building has the difference. In the point, the roof and the building through which when the resident, then you can also read there what the conditions of the calculating the center of mass and center of rigidity. It is showing that a pure translation in the horizontal directions and the not twice the verticals in the center of rigidity. Here now we have to go to the calculate the center of mass. How we can calculate the center of mass? For calculating the center of mass, we are using x bar is equal to summation of W into x. W is the weight or weight in kilonewtons and x is the distance and W into y by summation of y and the center of rigidity. Center of mass. You have to be calculate the center of mass. First of all, so we have discussed about the center of mass. Let's go to the in Excel formats. Okay. Here we have to be first of all we have to know to the buildings. If your building has symmetric floor, then you have to use the center of mass of the one floor. But here we have a buildings this symmetric different floor has a different uh, use for the different purposes, like the basement are used for the uh, parkings. Now per basement it also used for the parking. Ground floor there is the wall are the different and and the format are also different. There is the wall or not slab and up to ground first floor to 12 13 floors. Here I have a same models same floors, but in the 14th floor there is the different. So we have to calculate the two ground floor for the ground floor center of mass and rigidity for the ground floor, the upper basements and the ground floor and the typical floor. Typical floor include the first floor to 12th floor, the 13th floor. We have to calculate the 13th floor. That is there is only the floor. That's this only the third floor and other way is the roof. So we have the 13th floor and we have to calculate the 14th floor and we have to calculate the roof floor. That is the same similar. Okay. Let's go to the Excel format. First of all, we have to calculate the center of mass of a slab. Here you have to make the format like this: serial number, panels. That panel in panels means that the name of the slabs and the length Lx, Ly, length, breadth, and the thickness of your slab. Dead load. Dead load will be calculated by 25 into thickness. 25 into thickness. It is in kilonewton per meter square. Okay. Um, 25 into thickness and plus 20 into 0.025. That is the floor finish. I am also adding here. And the live load here I am using the 2 for the parking and the 2.5 for the parking and use 2 for the living rooms or any others all the rooms. Okay, their dead load has been calculated by dead load into area, length into breadth. Their dead load into length into breadth, that is in kilonewtons. Okay, live load is that is live load into length into breadth. Okay, and the total load, that is Z load plus live load, and x bar and y bar calculated. How we calculate the x bar and y bar? Here is the, and you can also can x bar and y bar. Okay, we have got the length, breadth, thickness, dead load, live load. You have calculated wx and wy. How we calculate wx and wy? You have got wx is the load, w into x, w into y. Okay, but here is the x and y. Most of the student waste the time to calculating the x and y and the length of breadth by measuring. In AutoCAD you have to measure all the length by using DIM dimension functions there is a there you can pass the lots of times, so waste all other time. Simple way to calculate the center of mass. If you have done the possible, you have to done the project in a model in a etaps. There you can easily calculate the center of mass and center of rigidity. Okay, here I am going to upper basement. First of all, we go here. We have calculated the basement floor, ground floor. That is difference. That's why typical floor, 13th floor, 14th floor, and the roof floor. Okay. Similarly, you have to calculate it. First of all, the panel one for the x and y, you have to calculate the length, breadth, x and y manually. You have to go there. If your slab is with the panel, this panel is this one. You have to just click here, right click. Okay. Go and click right click and go to the geometry area and there go to the geometry. There we got the center of x and the center of y. Okay, the length you have to length for the length you have to measure here. For the length you have calculate, that's the length, the sum of this length, that is getting lx length, and for the breadth you have to calculate this, and for the center of mass and rigidity, x and y, just click right click and there is the centroid of x and centroid of y, that is 12.344 and 24.193. Just 12.344 and 24. Similarly, you have calculate all the slabs. Just click name your type your name. You have calculate the length from this dimension, y direction is the breadth. Okay, and just click the right click and you have to go to the center of mass and the center x bar and y bar centroid, that is centroid of that slabs. You can hit the x, simply you have calculated. Okay, now similarly you have to calculate all the panels. Okay, the length, breadth, get to the time from the dimension, thickness has been same, and dead load has been used the formula 25 into thickness. If you slab to be at the floor thickness or not, that's your choice, and you have to use the live load, dead load plus live load in the area, and the x and bar you have got the etaps, and this you calculate it, and the sum of the loaded. Here you can sum the dead load, live load. There is a load of sum of load w, and sum of w, sum of x, sum of w into y, and for the x centroid of mass, that is calculate sum is w into x by w. We have got x. Similarly, we have got y, w into y by y. We have got the y, center of mass. Okay, and center of, and similarly, you have to calculate the ground floor. You have to go on the ground floor, and similarly you have calculated. If you have the same panel, then it will become the same, otherwise there may be the difference if your panels that I have same. Similarly you have to calculate all the floor, and next we go to the column. How we calculate the center of mass of the column. Okay, let's go. Center of column, you have to use the name. Here you have to add the b and d, that means the width and depth. There you can use this value like this, because if you are calculating this first using the preliminary conditions, preliminary designs, you have got the size different, but after the designing you have got the different size, that's why there is the change. So you have used the there so calculate, and in the further if you have increased or the decreased the size after the preliminary study to design for the check for the verify the conditions and the building safe building, there will maybe change. So that's why I'm writing there. You have to get the serial number, column ID 1234, width, depth, and height, that is the floor to height of the buildings. That you get the from the elevations or the height of the floor to floor height, and the date, and the load is the date, that is the dead load means the 25 into width into depth, width into depth into height, width into depth into height, that is load 25 into width into depth into height. And x bar and y bar, we have to I'm showing how you calculate the x bar and y bar. You have just go there, and for the for any columns here, what the column name is, just go a3. Okay, just go to the a3, um, that is a3, that's column. Okay, you have just you have to go to the, you have to write the column name, okay, and just you go to the center point and click the right click, just right click on the center point of the column, okay. With any plot that we have got, and there we got the global x and global y, 10.076 and 25 point. Similarly you have put there 10.03 and 25.9, and you have got the w into x, w into y. Similarly you have calculated all the, similarly we have calculated all the columns, and sum of load, sum of load, and sum of w into x, sum of w into y, and just w into x by y, w into y by w. You have got the x bar and y by. Similarly, similarly for the calculations of a beam, you can easily calculate, use the name beam width, width, that is with here I am going in our building process. Here I have primary beam, secondary beam, and the lift beam. So they are different size. So that is depth and width and depth. Um, Width and depth, length. We're using the formula, um, using this like this dollar sign. That means the easy for you after the changing the beam size or not. If you are starting the project, there is the calculate the center of mass. That is maybe difficult in the after that changes the length and the load. Load is 25 into width into depth into length, uh, x and y bar. Here we have to calculate the x length or length of the beam, a35, okay, a35, and x and y we have to be that is same, w into x, w into y, okay. Hmm. But we have to calculate the length, x and y, okay, a35. Just go to the e tab, a35. That's this is this beam. Okay, the share walls. There may be difficult to do. 3 and 4. No problem there. You have to just for the length. You have to click this right click. You have got the length 4.67, 4.6736. Okay, and for the center up, you have got the length. And for the x and y, you have just click the left or right column. If the left column, you just click right. Here you have got the center of x and center of y, center of x, center of x, center of x. That is, oh, this may minimize. There is just easy to understand. For this, you have got this folder. After the right click, x is, y is same. Here is y is same because from here, if you are the center, this is the origin, then you have to calculate from there to there. The x is, y is same. Y, that means the global y 25. For the x, for the longitudinal beam, for the x is, you have to global x at 10 plus length by 2. Use the functions length by 2. The y is 25.98. For the x, that is 10 plus length by 2. You have applied there. Similarly, you have calculated all the beams. Okay. Secondary beam you have also easily calculated. Here you calculate like this. That you got the length for the x bar and y bar. Or you have simply click here or anywhere to the column. Okay. If you were the joint, then you press there. There may be, there is joint. There is global x and global y. That is x may be 0, is 0. That means 0 plus length by 2, and the y is 12.65. That is 12.65. Similarly, you have to, and for the transverse beam, that's this is second beam or the transverse beam. You just click. There is in the transverse beam x axis, the global x. You use the length is this, and for the x, you have just clicked on the bottom. X is same. That is use the global x, and for the y, global y plus length by 2. Use this function for. Similarly, we have calculated for the column beam and for the wall. For the wall, similarly, where the wall is near to the beam. Okay. Similarly, the calculate the wall is a beam. You can see the in AutoCAD where is the wall. Then you go to the E tabs, and if there is a wall, then the beam x and y is similar to that wall. Okay, that is similar. And similarly, you have to calculate for the wall is also the length, breadth, that is um, name of the name, and that is meter in length. There is a length of the wall, and that length is effective length, that is subtracted the width of the column. Uh, After you have subtracting there, um, if this is your wall, okay, but there is, if this is a column, okay, here you add the column, this is your column, and here is a wall. But for if you are taking the length, if if there is a middle line, grid line, if you are taking the length of the here if you are taking, if you are right click, if you are using the 7.131 length, that is center to center length, that means the hair to hair length, you have to be separate the half of the width of the column and half of the width of column, half and half on the both side. That's why here I am effective for effective length, here I am dividing width by by 16 and by 16, okay, by you have to separate like this, and uh, and you have to calculate the breadth, that means the thickness of the wall, and the height that is floor to floor height. For the in height you have to be subtract the width, depth of the column, depth of the beam, okay, depth of the beam, that is 0.55, and the area with the area you calculate the length into height is the area. And the open, if there is a opening, you have, as per the code, you have opening at the opening 30%. If you are not know the how much opening there is, opening of wall, or what you have not exactly, you have to calculate, then you have to be calculate the opening from the dimension of wall, that is door and windows, otherwise you have minus the 30%, okay. And the load into area into thickness of the wall, and the x and y, similarly I am saying like this beam, you have to calculate it. And for the shear wall is also is similar to calculate the wall uh, length. You have got the length here, you have to go here you this is your shear wall, then click on right click, that's the beam, showing that here we get the length, and x bar plus x bar, that is geometric x plus length by 2 is x, and the y is global y, that's global y for this shear wall, okay. Similarly, calculate this. This is also calculated. And for the staircase, what we have to, the length and breadth, you have to calculate the length and breadth from the AutoCAD, from your staircase, and the area length into breadth, and the thickness no need. Dead load you have to calculate. Dead load, that means there, if you have designed the staircase design, there is the dead load, that is the weight. There you have got the weight on going and landing. Average of this 25 into 27, you got the average, take the average for the dead load, and live load for the staircase 3, and dead load, that is dead load into area is dead load in kilonewton, into, that is kilonewton meter, okay, kilonewton meter, and into area we have got, here we got, and the live load is in kilonewton per meter square. There is also in kilonewton per meter square. There is also in kilonewton per square. And you have multiplied the area. You have got the load, total load, x and y. X and y, you have to be calculate the center of x and y and from the AutoCAD. Similar, simply. Um, and you have calculate also from here. If this is your staircase, then get the this. You have to go in the joint, the global x and global y you got, and for the x bar, length by 2, and y bar, this is the same, simple. And the center of mass, that is you have calculated the center of mass of the wall, and the each and every floor I have calculated, typical floor, roof floor, and the beam also calculated. Beam has the same on the basement, ground floor, typical floor, 13th floor, 14th floor, And the roof floor, similar the column and wall. Column has the same, and the beam has also the same. If there is a change, then the change in the center of mass. Center of mass of the upper basement, ground floor, typical floor, 13th floor, 14th floor, and the roof. Okay. Similarly, you have to make the member, all the slab beamer and load. This load has been on the slab load. There you just that is just click the slab load on the ground floor. Just you get the format like this: load x y w into x, that is w into x, w into y. Make the format, and for the x just click equal and go to the slab, and there is a load, total load. Just click here and enter. Just this value has been come. Okay. For the x 16.6, just click OK. Go to the slab, select this and enter. You have to make the format like this: x and y, you get w into x, w into y, and similarly you have got all the value like this similarly, and you have calculated x into w into x by w into y by w y. Get similarly the all floor you have to calculated. And now we have to go to the center of rigidity. For the center of rigidity, center of stiffness, we are going to calculate. There is only the two member have been participated in the center of rigidity. That is the column, and the another one the shear wall. Okay. For the column, for the shear wall center of rigidity of column, just for the column, x bar is equal to summation of kyy into x by k summation of kyy, and for the y bar is summation of kxx into y by kxx. That is different. You should not have to multiply with x with x and y with y. That is the alternative. Okay. And the k means 12 ei by l cube. L is this, L is the height, I is the moment of inertia, that is bdq by 12. If the x-axis, if the x, then bdq by 12. If I y is, then we have you db by 12. Okay. And E the modulus of elasticity, that is 5000. E is equal to 5000 root under FCK, that is 25 or the 20 MPa. As per you use. Okay, there is everything. Okay. And for the center of this value is only used for the column. You should not have to use this value as for the shear wall. Okay. Because shear wall, in the shear wall there we have to use the different formula for calculating the center of rigidity. If you are using this, there you value got the make. First of all, we go just discuss here the center of rigidity. You have to get the column width, depth, length. This all value, the serial number, column width, depth, length, x, y. Up to here you have just already calculated from the in the center of mass. Just copy it. Okay. Here you got, and after that you have to calculate center of mass and the x-axis, that is bdq by 12. For the y-axis, bdq by 12. For the in my by dbq by 12. Okay. For the stiffness, we have 12 e by l cube. 12 e means the 5000 root under fck, rate 25 into I imxx, that is ixx. For the xkxx, we are using ixx by bdq by 12, that is 12 e by l cube, that is height, l length is height, by 12. Similarly, you have calculated the y. Here you only use the iyy. Okay. And kxx into y, you have to be understand that kxx into y, not kxx into x and kyy into y. There you have to use the perpendicular value. Okay. Kxx into y and kyy into x. After that, you have sum the kxx, sum of kyy, kxx, kyy. There you got the sum of these all value. Okay. And after that, kxx, that is kxx kyy into x by kyy, that give you got kxx. And for the y, kxx into y by kxx, that you got y. Similarly, for the another for this all value has been given from the center of mass, and you have also manually calculated. These are the same. Now for the shear wall. For the shear wall, we have using this formula, other formula. We have also used for this formula is used for column, and these are the same value, okay? And there is a three mistake, that's why I'm writing on the column and shear wall. This value is used, but this value is only used for the column. But this value, if you are using this value, this is for the both column and shear wall. What is the K? K is the E times E is the modulus velocity is 5000 root under FCK. T means the thickness of the wall. H is the height of the wall, and L is the length of the wall. H by L times H by L whole square plus 3. This is 3. Okay. E into T by whole upon H by L times H by L whole square plus 3 using this formula. Here we have also checked the by using this formula center of rigidity of shear wall calculator or not. If you have you have all these value in the center of mass and rigidity, you have calculated the name, length, breadth, height, x and y. Just you calculate MOY. MOY is the BDQ by 12, that is BDQ by 12, and DBQ by 12. AXX is equal to 12 EI by LQ, 12 EI by LQ, and K into XX, K into YY, and sum of all these value KXX into KYY. Here you calculated 13 point, that is KYY into X by KYY. You have got the value 13.027, and KXX into Y, KXX into Y by KXX. You have got the value 11.05. But this value has been calculated in this, but after using the real formula of the shear of rigidity, that is you have to calculate the K, that is already I have discussions. E into T. E means 5000 root under FCK into thickness H by L whole square plus 3. Here you have given 5000 into FCK, that is E, into that is D, thickness that is uh, thickness of a wall, that is breadth. Here you are using thickness of a wall, into height by length plus height by length square plus 3 into 1000 to using this for you manage the unit. Okay, you have got the kx k, and using k into x, k into x, k into y, k into x, and sum of the kx's and ky. If you are using kxx, kxx, kx by k, you have got x value, ky into y, you have got the y. Here you got the value difference. There, if you are using the e into t by h by l whole square plus 3, then you got the 15.29 and 12.70. But you have using the 12 e by l cube formula, then you got the 13 value. There is the mistakes. Okay. For this confusion, many of the students are having confusion on to calculating these 12 using the shear wall, but also the 12 e by l cube, and there you got the mistakes. That's why I am going to showing this in these videos. This and similarly you have to calculate it for the other floor, ground floor, typical floor, roof floor. Okay, and after that, center of rigidity of buildings, you have to get similar like the center of mass, center of rigidity. Actually calculate kxx into kyy, kx into y, and kxx into y, kyy into x. Shear wall, for the shear wall kxx, that is kxx into g. Simply you press the just for the x, it's for the upper basement, just click, that is 12, x is 15.2, just click is equal to, go to the shear wall and just click here and open enter. Here you got the meeting point. Similarly you have to calculate the column and the kxx into x, kyy into y, and you have got this value, center of rigidity, center of mass, and center. And for the eccentricity, you have to check the eccentricity. For the eccentricity, what we had, what the x, the upper base, all the floor you have got the center of mass in the x and y, center of rigidity of x and y, and even the eccentricity, that is the difference. This minus this minus this. that is Ex is equal to center of mass of X, center of mass, center of rigidity of X. You have calculated for the Y. Y, center of mass of Y, center of rigidity of Y. You have calculated EY. Similarly, you have calculated all these, all the floors. And here Exx by L, that is Exx by L, the percentage for the for the percentage in the code, and they discuss in the centricity should must be less than 5%. Okay, that's why here I'm using mm, exx into exx by length. If this is your building, if this is your building, like this your building, then you have to, if there is no just mm, mm, this is your building. Okay, just click here. mm, mm. This types of, okay, there I am also separating this. Okay, this is the building. Okay, there is a floor plans. Now what you have, the E axis by L into 100, E by Y into B by, that is L. L is the length. E for the E axis you have used the length of X, that is length from here to here, length from here to here, outer to outer, the maximum length dx, and using the b that is gy, that is from here to here. If there is gap, if in a upper floor here there is a gap, there is a lots of gap, but you have to use the maximum x, maximum length here to here. That is maximum length, that is x. Use the L, and for the maximum b here to here, just for the L and for the L and V, just click, just go to there, and for the global X, from the global there X, that means here to here, just sum all these value for the X, and for the Y, just sum all this value. Okay, and similar way you have also calculated like this. Go to there. I think there is no right. Okay, yeah, for the length, you have to click here, that the global X is 28.55494, and the for y-axis just click here anywhere, line, this line, you have got the global y at 25.98, that is your y, that is b. Okay, you have got the b. Okay, these all value are the 5%. Okay, there is only 1 2 3 or 4 value has been not the conditions, meet the conditions 5%. What we, if what we can do if the condition is not met. In the next video we are going to discuss about mm, how to override the eccentricity. If your center of all the floor has been met but the some floor has not meet the conditions, like up to the 13 or 14 15 to 15%, you have to override the eccentricity. Okay, thank you for watching these videos.